Hey there, hope you're doing well because I know I certainly am. I finally got to get BGP working on RouterOS version 7 to do multi-protocol type of stuff, especially where we want to maybe span a VRF between 2 or more provider edge routers to deliver services like a customer MPLS solution, which is really awesome. So think of this video as a teach along or a play along or sing along or whatever you want to call it, where I actually encourage you to start up your own EVE-NG or GNS3 topology or something and try and add the configurations as I do it in real time as well, just so that you can also get a bit of a feel for it, because I do go through the whole setup from start to finish. We will have blank routers and we will configure everything from scratch. So pardon that the video is so long, but I feel like this is the best way to learn and I hope you enjoy it. So let me know what you guys think, and also very soon Happy New Year to you all as well. So I'm actually really happy and tired, but it's been a wild year. So let's continue with the video. So we have an EVE-NG topology in front of us that we are going to set up from scratch to build our ISP network that will allow us to service customers on an MPLS scale using RouterOS version 7. Try and not overcomplicate the configurations that we will be going through, because I am going to simplify this as much as possible. And for anything more in detail like BGP or OSPF or MPLS, I recommend watching one of my videos that just focuses on that specific segment of configuration, because we're kind of going to be using all of that information that I've posted over the years to build this network so we can actually do this VRF spanning using BGP. Now that's going to be freaking awesome. Now, first thing I recommend we do is actually just start up our devices. Now all of these devices have been blank, they've been wiped, so we have no configuration on them. So we want to configure a few things. A couple of things that I want to set up firstly is just my IP addresses between my routers, because I do have my provider edges, so PE1, PE2 and PE3, which are all connecting directly to my provider 1 router. So I want to make sure that I have the IP addresses set up between these routers, as well as their loopback addresses, which is these red IP addresses that you see either next to or above the nodes. What is a loopback address? Well, it's an IP that we can assign to a virtual interface, like a dummy interface, a loopback address, so that even if an interface goes off on the router, that address will always remain live. Now that is hyper useful if you're using stuff that has redundant paths, perhaps multiple links, and you want to deliver a service on a specific IP that you know will never go down. Loopback addresses are great for that, because then you can just advertise that route over your whole network, and then if a path does go down, a redundant path can just take over and services will keep working. So what we're going to be doing in essence is be connecting using BGP between our provider edges on their loopback addresses, so that we can actually provide a service to customers where we will be spanning a VRF between, it could be different locations, it could be different geographies. There's so many use cases for this really, but it's in essence, it's so that the customer has their own little cloud where they can do whatever they want with their network, and there won't be any overlapping subnets, and they can just do what they want to do. It's their network, which is super magical for me. Let's start off with our provider router. So I'll just log onto this device. I'll actually do the base initial setup using Winbox. So let's just go onto Winbox. And then with Winbox, we will be able to obviously do some basic configuration. So let me just find my neighbor. This is my provider router. It has been blanked, so I need to configure everything from scratch again. So let me log in, set my password to my lab password. I've changed that. So let's just close all the windows and make this super simple. First thing I want to do is obviously just maybe set the host name for this device so that we always know what we're working on. So my system identity, I'll make this my P1. Second thing I want to do is maybe enable ROMON so I can manage this node and other nodes using the ROMON network for ease of access with Winbox. So let's just do a tools, ROMON, enabled yes, apply. Next step is actually the IP addresses that I want to bind, but let's add that bridge first, that loopback address. So I'm going into my bridges, I'm going to hit plus, and then I'll call this my LO interface. I'll just apply this, and then LO0 is now an actual interface on the device as well. So now I can navigate to my addresses, and from my addresses, let's start adding our IP addresses to our interfaces as well as the loopback address. So first IP I want to add is maybe the loopback address, which was 192.0.0.254. And that I will be binding to my LO0. I'll hit apply, hit OK. Done and dusted. Next address I want to add is my router's interface IP. So if I look at my topology, we can see I have 10.0.10/30, 10.0.20/30, and 10.0.30/30. Now, coincidentally or lucky for me, it's PE3 is .3, PE1 is .1, so it's really simple and straightforward for me. But I do recommend as well, whenever you do some type of IP address planning for your network, try and sync stuff up like that so that you kind of know what device you're going to be working on. If you're in a specific address range or pool, it just makes your life a lot easier. So let's add the address of 10.0.11/30 to my Ether1, and it will be the same for all of my other networks. It will be .1 will be my provider router, and .2 will be my provider edges. So in Winbox 10.0.11/30, you will be going to Ether1. Next up, 10.0.21/30, you will be going to Ether2. And then lastly, we have 10.0.31/30 going to Ether3. I will hit apply. Now I have my basic IP addresses configured. This is fantastic. So now I'm just going to quickly do the same on the other routers via Winbox and the command line so you can see how quick and easy it is. So let me go back onto here. I'll click onto my provider edge 1. Provider edge 1 we'll still do via Winbox. I just need to enable ROM-on quickly. So we'll do a tool ROM-on set enabled yes. And now I should be able to pick up this router in my Winbox in a terminal station or in the neighbors. So if I look at my neighbor list here, I can just connect to the ROM-on network. Let me just set my password. And now in my ROM-on neighbors, I should see this new router. There we see the identity is just MikroTik, so I can just connect to this. And this is my PE1. So let's just navigate to the PE1. And then similarly, we'll do a few things. ROM-on's already enabled, so I'm not going to worry about that. But I do encourage naming our device. So this we will call our PE1. Next step is our bridge, which is going to be our LO0. Perfect. After the LO0, let's add our IP addresses. So since this is the provider edge 1, I know that 10.0.12/30 on Ether1, that is the uplink to my provider router. I will apply that. And then my loopback address is 192.0.0.1. Did you guys know that 192.0.0.0/24 is also kind of like a private subnet that you can use? It's actually great for using for stuff like loopback addressing, to be honest. Or you could just do IPv6, to be honest. But I'm just going to leave this on IPv4 for now, and I'll make separate videos regarding IPv6 when we get there. Alright, so PE1 has been done. And that's just the basic network settings. So if we look at the terminal, from my PE1, I should at least be able to ping 10.0.11, which is the provider router, which I can. So I'm happy with this. Let's quickly do provider edge 2. Oh, and FYI, I'm going to ignore PE3. We won't touch that. It's more or less just an addition where you can add on. We might do that at the end. I just want to show you how to get these two provider edge routers, PE1 and 2, going from the beginning. PE2, I'll just do this via command line quickly because it is super quick. So password. So first step is system identity set name, PE2. Tool ROM-on set enabled in case we want to log onto the device for management. Then I just want to do an interface, bridge add. This will be our LO0 bridge. Then I want to just add my IP addresses. So IP address add, address 10.0.2.2/30, interface Ether1, because this is also the uplink from my PE2 on Ether1 to my provider router on Ether2. And let's just add our loopback address as well. So loopback or IP address add, address equals 192.0.0.2/32, interface LO0. Cool. So if I do a ping 192.0.0.254, will it work? No, it won't work because I don't have any routes yet. But if I ping 10.0.2.1, that should be pingable. Alright, so we do have the basic foundations for our ISP network going, which is perfect. So I'm really happy with this. What do we do now? Well, we can either configure our customer edges or customer premises equipment, and I'll actually leave that for last because I'd like to first just get the whole ISP network running. So if we have just basic network connectivity, what else do we want after this? Now, I would like to actually learn some routes dynamically. I'd actually like to obtain these loopback addresses without having to statically add IP addresses or routes the whole time, because that will be a mess, especially the larger and bigger our network starts to grow. So let's add OSPF. I think that is a great dynamic routing protocol for our interior gateway, and it will serve our needs perfectly. So first thing I want to do is just get back on the provider router, so P1. And then from P1, a couple of things I want to do is firstly just go into my routing tab, go into OSPF. Then from the OSPF, let's add a new instance. Now this will be running version 2. If it was IPv6, I'd be running version 3. I can give this the name of backbone, and I can leave everything else as is. If I click apply, it will just generate a router ID that is bound to my loopback address. Reason being, if I go to my routing and router ID, since I have a bridge interface with an IP attached to it, it will already dynamically add that as a possible router ID candidate for me. So I could have added this statically as well. I can actually also just copy this and leave it like that, and then that's another way. But now we have a dynamic router ID that can be used across the board on this device, so that's fine. Next step is we want to add our area. So area is also just going to be my backbone. The instance will be the instance I just created, and my area ID is obviously going to be 0000 for my backbone. I will leave the type as default. I'll hit apply, and we are almost done with the provider router. Next step is the interface templates. So from here we can click on the plus. I can specify my area as the backbone. I will leave the network type as broadcast, even though this is technically more like point to point, but I'll leave it on broadcast just for now. And our interfaces, this is going to be a Ether 1, Ether 2, Ether 3, and my loopback. I want all of these interfaces to be participating with the OSPF. My networks will be 10.0.10/30, 10.0.20/30, 10.0.3.0/30, and then lastly my loopback address, which is 192.1.0.0.254. Sorry, I made it like 192.168 there for a second. And there's nothing else I really need here. So this is pretty straightforward. I'll hit apply, and there we go. So technically the OSPF has been configured on this provider router. If I look at my neighbors, nothing's going to be happening. My LSAs is just what's on this router. So nothing's really happening because we haven't configured our second router yet. So let's do that. Let's go into our provider edge 1, and then from provider edge 1, routing, OSPF, and then with the OSPF, same process. It's instances, version 2, name is backbone, apply, areas, name is backbone, apply, and our template. So if I click on the template, I can specify my interfaces, and this is going to be a little bit less because now I just need my Ethernet 1 and my loopback. So pretty straightforward. So Ether 1 and loopback, and my networks for my PE1 is 10.0.10/30, and well, that is my actual my interface network, and then my loopback is 192.0.0.1/32. I shall hit apply, and this should actually bring up OSPF connectivity between my provider edge 1 and my provider router. So if I look at my neighbors, I can see I have a dynamic neighbor up here. I have a full state, which is awesome. You always want to see that with OSPF, and I can look at some of my LSAs. So we know the OSPF is working. Another way we can check is just look at our routes. In the routing table, we can see what routes we are learning. And there I can see I am learning 192.0.0.254, which is the loopback address for my provider router. So I'm very happy with that. Now let's do the setup on our provider edge 2. And this I'll do again from the command line. And it's again pretty straightforward. It is just we are going routing, OSPF, we add an instance. We can just give it the name of backbone. And if I hit enter, it will be fine. If I do a routing OSPF instance print, you'll see it is version 2 and it's already determined VRF main router ID, whatever that dynamic router ID is that I'll get. Next step is routing OSPF area, add, name is going to be backbone, and the only important bit here to set actually is our instance, which is also our backbone that we created. It will automatically fill the type in as default, and my ID will be 0000. So let's hit enter. And then lastly, routing OSPF interface dash template. We'll add this. Now let's specify our interfaces equals, and this is going to be our Ether1 and LO0, and then we have our networks that we want to set, and this is going to be 10.0.2.0/30, as well as 192.0.0.2/32. And this is so weird, I don't know why Eve and MikroTik has this weird interaction where it's almost like a bug where you see it just keeps going up like this. The config's still taking just fine, it's just a bit of a visual glitch. So we have our interfaces, we have our networks, we do need to specify our area as the backbone area that we created. And is there anything else that I need or want? Not offhand, no, this should be it. So if I hit enter and I do a routing OSPF interface-template and I just print this or I export it, you can see exactly what the configuration was. So let's just see if the OSPF has formed a neighborship as well. So routing OSPF neighbor print, and there we can see we do have a neighborship with the provider router and it is in a full routing state. And if I type IP route print, we can see I am dynamically learning some routes. What is important to me is the loopback addresses that I'm learning, because now I am learning 192.0.0.1, which is actually PE1's loopback address. So let's see, can I ping the PE1 address from my PE2 loopback address? And I can. Yay! So OSPF is done and dusted. Next step is we're actually going to have to set up the MPLS portion, and this is also going to be a bit of a breeze because MikroTik makes this also super easy and quick. Let's start with our provider router. So from the provider, we can go to our MPLS tab, go into MPLS. First thing we need is to just determine what the LDP instance is going to be. If you don't know what LDP stands for, it's Label Distribution Protocol. It's kind of how MikroTik does its magic with MPLS. It's the thing that figures out what labels to attach and remove and all that wonderful stuff when it comes to MPLS. So our LSR ID will now just be our loopback address, which I'm going to make 192.0.0.254. And my transport address is going to be exactly the same. No difference. I'll hit apply. And now I can set my LDP interface, and this you can think of as the interface similar to OSPF that's going to be participating with this protocol, that's actually going to be using it. So in our case, it will be our Ether 1, 2, and 3 for provider edge 3 when we decide to configure that. And I'm just going to add it like this. So Ether 1, Ether 2, and Ether 3. Perfecto. That's done. That's really it. So next step for me to actually get this piece of the puzzle working is configuring MPLS on a neighbor, on another device. So let's do that on PE1. So from PE1, let's go into our MPLS, LDP instance. This one's LSR ID will be 192.0.0.1. My transport address will be 192.0.0.1. I will hit apply. And now this LDP interface is just going to be Ether 1. I just want this uplink from PE1 to participate in the MPLS. So if I go back onto Winbox and I look at remote mappings, I should actually see there is a table being formed here that will tell us what labels will be used to get to specific hops and such. And it's really cool. It's really basic. If you've never heard of MPLS, it's really this, they call it the 2.5 routing protocol because it works between layer 2 and layer 3. So it's using IP address information, but it's kind of switching the IP address information between your devices. So it's a technically faster, but it's used for various services as well. And I mean, this is where we're going to also be spanning our VRFs. We'll be using LDP with our BGP to actually pull and export and import route distinguishers and such, but you'll see when we actually do the BGP portion as well. So PE1 is done. Now let's just get PE2 done. And again, this is really straightforward. All we're going to be doing is MPLS LDP instance or set. So we can set our, we want to add one. We can set our LSR ID as 192.0.0.2. and we can set our transport address as 192.0.0.2. Perfect. And now we just want to add our interface. So MPLS LDP interface add, and this interface will be Ether 1. Because if I look at the topology, it's also just Ether 1 for PE2. Perfect. So now PE2 is also connected to the MPLS. And if I go to the provider router and I look at this provider router's remote mappings, we'll see that this table is a little bit more full. It knows a little bit more about where to get what and what labels and such to use. But that's actually it. That's it for the MPLS portion. So how do we make this customer MPLS work? How do we make the VRF spanning work? This is where BGP comes into play. So we are going to be using BGP as an interior gateway protocol, or IBGP, sorry, I should say IBGP. We're not using it just as an interior gateway, but in essence, we'll be using the same autonomous system number between our peers to be exchanging route information. And what's nice about BGP is if we go into, let me go onto the provider edge and I'll go into BGP. If you click on this connection and you see this address families here, AFI, this is basically what makes BGP also so powerful. Besides how great it is at learning routes and doing the internet for us, you can run other protocols inside of BGP. So it can exchange IP, it can exchange IPv6, it can do layer 2 VPN. So stuff technically like VXLAN as well as VPLS. BGP is great for that type of stuff. And then we get our VPN v4, or what other people tend to call layer 3 VPNs, where we can span a customer's VRF between provider edges, which is super cool and it's a really nice feature. So let's actually set up the BGP portion. And for this, all that we're going to do is firstly go into my template. With our template, I'm just going to update this a little bit. I'm going to make the AS for our peers 6500 or 65,000, sorry. And our AFI, I want to make sure, let's just say, even though we really just need VPN v4, maybe in the future I want to do a few other things, I can do IP. And you're not limited to this. If you want to later on update your address families, you can do it. It's not going to be a train smash. So let's apply this. I wonder why this is red though. This doesn't look right to me. Anyways, let's just continue. So let's add our connection, and the PE1 will be connecting to PE2 to actually span this VRF across. So I'm going to call this to PE2. Our template I'm going to use is the default template. I don't need to fill in the AS or AFI because the template already contains that information. So the real thing that I need here is my remote address, which is going to be the loopback address of PE2 because that is what I want to use. My remote AS is going to be 65000 and my local address will be my loopback address. Think of this as your update source address. My local role is going to be IBGP, and I will set this to connect and listen. I will hit apply, and that should be it for this specific PE. If I look at my sessions, nothing's up yet, but I don't think anything will come up because there's nothing on the other end trying to connect as well. So let's configure the BGP on my PE2. So if I go to my terminal, I can do a routing BGP template set. Let's just print the template first. Then we can set this AS. We want to make 65000, and I want to set my AFIs as IP and VPN v4. Hit enter. Then I want to do routing BGP connection add. Our name will be to PE1. Our remote.address will be the loopback address of router 1, which is 192.0.0.1. Our remote.as is going to be 65000. And see, MikroTik is doing this thing again. That's fine. Our local.role needs to be IBGP, and then our local.address is going to be my loopback address, which is 192.0.0.2. Our template needs to be the default template, which has that address family and AS of us already configured. And then I just want to set connect yes and listen yes. I shall hit enter. And let's see what configuration it spits out. So if we do routing BGP connection export, this is in essence all the details that we set. So it doesn't look messed up like this while the terminal was freaking out with me typing the commands in. But ideally what we want to see now, if I do a routing BGP connection session, if I print this, I should see a session that is established, and I do see the session is established, which is great because it means our peers have formed a relationship and is able to exchange routes and do stuff with the protocol. So we are off to a very, very good start. Now we've got all of the baseline stuff down, but we need to now actually configure our VRF. So how do we go about Configuring a VRF, well, it's pretty straightforward as well. Firstly, we will just log on to our provider edge, and then with our provider edge, we need to determine which interfaces will exist or be bound to our customer. So we will create a new VRF called cust1 for customer 1. You can imagine this is some big enterprise and they need an MPLS service from you, and you're going to provide it to them now. How are we going to do this? Well, we're going to go into our routing, and from our, we're actually going to go into our IP, and then from IP, we will go into VRF, and from here we can add a new VRF. So if I click on the plus, we can give it a name, and I will make this cust1, and now I can specify which interfaces belongs to cust1. This could have been VLANs, doesn't really matter. As long as it's an actual interface on the MikroTik, you can assign it to a VRF. Now note that when you assign it to a different VRF, it will exist in that VRF. It's not going to exist in multiple VRFs at the same time. So I'm going to now set ether2 for customer 1, because ether2 is technically belonging to customer 1. Now I want you to check this out. If I go into my IP routes and I look at my routing table, I will have this little drop down box, and we can see there is a cust1 in the drop down box. If I click on this, this will actually be the routing instance for customer 1. It will show which routes exist for that customer, how to get to those destinations, and all that wonderful stuff. At the moment we have a blank routing table because nothing's been added. Now, first thing we want to do is maybe just add the IP address to our customer edge, to our client. So to site A, we will bind the IP address of 164.100.1 to our provider edge on its ether2 interface. So let's do that. 164.100.1/30 on ether2. I will apply this. And now you will also see in the routing table in the background that this customer 2 or customer 1 routing instance or VRF has added this address. It's a directly connected route for that interface. So we have a single route for this client now. But how do we actually do the VRF spanning? Well, this we do from our BGP as well. So we can go to our routing BGP, and then from here we have a nice little VPN tab that MikroTik added quite recently. I'd say 2, 3, 4 builds ago maybe. But this tab allows you to now create a route distinguisher as well as import and export specific route distinguisher information using MPLS. So let's quickly click on this plus, or using BGP I should say. So route distinguisher, what do we make this? Well, you can make it a various degree of things. Some people tend to just like to make it their own ASN or their own AS with a colon and then something for the customer like 1 for customer 1. With MikroTik's documentation, you might see something like 1111:1. That's also fine. Just note that this is the type of format that you're going to be making it in. It doesn't need to be 1. You can make it 200, you can make it 50, whatever you want. But let's leave it as 111:1 for customer 1. Our VRF. Now here we select which VRF we actually want to advertise or send out to our provider edges. Now I'm going to be using cust1 because I want their VRF to be sent out. And now we can set the label allocation policy per prefix or per VRF. I will set this to per VRF. And now we can set our import route targets and export route targets. Now since this is just for the single customer, this is very straightforward because now we can just import 1111:1 and export 1111:1. This will now allow us to send out the routes for this route distinguisher as well as pull in any routes for this route distinguisher. If you wanted to import stuff like your management route, you can add some additional route imports and stuff, but do note that is a little bit more complex, and I've covered this in separate videos as well, but I want to keep this as straightforward as possible, so we'll just do the single VRF for this customer. And now we can also set redistribute. Now similar to your other routing protocols, you can now set what route you want to advertise to your peers. So maybe I want to advertise my connected and maybe my static routes as well. Maybe even other BGP routes that were connected or OSPF. It's up to you, but I'll just leave this for connected and static and I will apply. So now my provider edge 1 is done. Let's do provider edge 2. So provider edge 2, let's just quickly check its settings. So 164.200.1/30 will be for the provider edge 2. So let's just firstly add the IP address. IP address, add address equals 164, what is it, 200? Sorry, my memory is like a goldfish there. 200.1/30 on our interface Ether2. Next step is the VRF, so we can go IP VRF add interface equals Ether2, and our name will be cust1. Cool, so VRF portion is done. So if I do an IP route print, it will help if I fix the typing correctly. We can see there is some stuff for add cust1, but I can also just do something like where VRF or where routing table equals cust1. This will then give me customer 1's routing table in the command line. Similar to Winbox really, it's like clicking on that drop down and then selecting cust1. Alright, so now let's actually do the BGP VPN portion. Now for this, pretty straightforward, routing BGP VPN. We're going to add it. First thing is we need to specify our route distinguisher. So in our case it was 1111:1. It's fine. Next step is we need to also just set our import route targets, which is 1111:1, and our export route targets, which is 1111:1. And the MikroTik is doing that funky thing again. We also need to set our VRF, which is cust1, and we need to set what we want to redistribute out via the BGP VPN. And this we're also just going to make connected and static. I will hit enter. Oh, and I need to say this is per VRF that I want to do. Nice. So, quick question, if I do an IP route print where routing table cust1, how many routes do you think there will be? Will there just be that one connected route, or will we see some more routes? Let's see. Whoa, crazy. I can see I have a route for 164.100.0/30, and the gateway is via my PE1, which is crazy because PE1 is quite a distance away and it shouldn't just know about PE1, but the routing table understands how to get to this information. But what I want you to see is if I do a ping to 64.100.1 via the VRF of cust1, what happens? I'm getting timeouts, but I should source this from my 164.200.1, and now I actually get a bit of a response. So this is really looking good. Now I kind of think that my routing is working on my provider network, on my ISP network, but I don't have any CPEs configured yet and also don't have any routes configured for my CPEs. So let's quickly do the CPE section. This is going to be super quick. So what I'm going to do is just log on to CPE1 quickly. And we'll just enable ROMON. So tool ROMON set enable yes. And then we'll connect onto that CPE1 via Winbox and just do a basic setup. So if I go to my neighbors, connect to ROMON, find my CPE1, there we go. It's just this blank MikroTik at the moment. There it is. So let's just zoom in. And then what I'd like to do is just go into my system identity, set the hostname to CPE1 for our client's equipment. Let's add their IP addresses. So 164.100.2/30, that is going to be bound to Ether1, it's our WAN address. And then we're going to add 172.16.0.1/24 to Ether2, which is for our LAN. Because ultimately we want the LAN subnets of this client to be able to access each other as if they're on this corporate MPLS network and they can just communicate directly to each other, which is awesome. So let's quickly see. Another thing that I maybe want to add is just a route out. So I want to say if I want to get out to anywhere, use the gateway as 164.100.1, which is PE1's address. Perfect. And that's really it, I think. So if I do a ping here from the customer's equipment, and I ping 164.200.1, which is PE2's IP address that will be going to CPE2. So let's just see, can I ping that? I can, but it's because I'm pinging it from the WAN. Can I ping it from my LAN address? So 172.16.0.1, that's timing out. Why is it timing out? Well, because PE2 doesn't know how to get to this address for the CPE. So to fix this, we already set a redistribution for PE1. So if I go into the VPN, I've set it to redistribute static and connected, but if I look at my routing table for cust1, I only have a connected route and then a copied route from the MPLS, so to speak. So what we can do is hit the plus And then from here, we can actually now add our destination as 172.16.00/24 with our gateway being the WAN IP of CPE1, so 164.100.2. And now this is going to be trippy because I need to specify add cust1. If I hit apply, we'll see that route appear in the routing table. If I take out the cust1, you'll see there's a weird thing, it doesn't really know what it's doing. So that's another thing that feels a bit weird for me on version 7, but it's how it is at the moment. So perfect. Now, is this route going to be on my PE2? Let's quickly take a look. If I go to PE2 and I do a route print where routing table cust1, cool, I can actually see that route does exist. So if I go back to my CPE, can I now ping 164.200.1 from my LAN address? Yes, I can. So we are basically done with the setup. Last step I want to do is just quickly configure the CPE2. Now CPE2, admin blank, I'll do this all from the command line just to again show you how quick this is. So system identity set name, CPE2. Let's just enable ROM-on in case we ever need it. Tool ROM-on set enabled, yes. Let's add our IPs, IP address add 164.200.2/30 on my Ether1. We'll do an IP address add, address equals 172.17.0.1/24 on our Ether2 for our LAN. And let's just add a route out. So IP route add destination with our gateway being 164.200.1, which is the WAN IP of PE2. Hit enter and perfect. This is going to work. Let's test it out. Can I ping 172.16, which is the LAN IP of CPE1 from 172.17.0.1, which is the LAN IP of CPE2? Can I do that? No, I cannot. The reason is because I don't have the routes for that on my PE2. So let's just quickly fix that by navigating to PE2 and let's fix it. Let's add a static route out. So we'll do an IP route add destination. And we'll say if you want to get to 172.17.00/24, the gateway will be 164.200.2 at cust1, and that should be it. So if we do an IP route print where routing table equals cust1, we can see what our routing table, oh, I forgot one thing with that route. So if I do IP route print, I just need to fix this one route I added. So 172.17.0.0/24, you can see I've added the add cust1 there, but I didn't specify the routing mark. So let's just fix that by doing a routing or IP route set routing table equals cust1 for line item 0 is what I see there. So let's just print this. Okay, that looks good. If we do a route print where cust1, we can see our routing table for customer 1 looks good. So now the proof is, does the ping work? And I can see it did start to work. Awesome. So if I go to my CPE1, can I get to my CPE2? And I should actually be able to. So if we ping 172.17.0.1 from 172.16.0.1, does that work? It does work. So we do have a way to span a VRF on router S version 7, and it works fine. It's going to be just dandy, and in theory you should have the same experience, although I do highly recommend firstly labbing this, seeing what your own experience is, and only rolling this out if you really need to, because I do feel like BGP and even MPLS to an extent still needs a little bit more cooking time on MikroTik, but it is at least serviceable. One of the big downsides for me at the moment with this type of solution is it is really not that scalable, because the more provider edges you add, the more BGP stations you need to form. Because let's just go to this map. If you add this third or fourth or whatever provider edge, they all need to be meshed together. You'll need to have a session running to each of the devices, which is really not a fun thing to do if you start managing a lot of routers, 100 routers, 200 routers, 300, you know, it starts to become a mess. But for a small ISP, I definitely think this is fine. Ideally, what you'd like is something called a route reflector, and that could have been your provider router. All of the devices could have formed a single BGP peer to the route reflector. Route reflector could have connected to all of the peers, and that would have been a much cleaner and easier setup to manage as well. But alas, that doesn't work yet. So this is the closest thing we have to span VRFs using BGP with ROS version 7. I know this might seem like a crazy lecture because there's so much stuff that we're covering, but really this is where you start getting into a lot of the really powerful things that you can do on your MikroTik or on your router, especially when you want to start doing really big ISP or carrier grade stuff. Anyways, I'd like to thank you guys for watching. I'd like to thank my YouTube and Patreon members for helping support the channel, and I'll catch you guys in the next video. See ya.